Now, of course, with every paper, video, and in general, you must always read the instructions. And in this case, you cannot use a calculator, okay? So it says here you may not use a calculator to answer any questions on this test. Another key point to know is that you always have 40 minutes to answer this exam. And the way I always picture it is 1 mark per minute. Depending on how many marks, always try and calculate and divide it into it. So follow instructions, work as quickly and carefully as you can. And if you need to do working out, guys, you can use the big box around it. So this is your nice working out box. I also do my working out around the page. So, I mean, that's fine as long as you're able to put any important working out inside here. Personally, always make sure you put your answers into this box here. So this is where the answers go, okay? So quite obvious, but at the same time, it's always good to know just in case. Okay, let's jump straight in then, yeah? So let's go. All right, number 1. So the numbers in the sequence increase by 14 each time. So write the missing numbers. Okay, so let's go from here. So you can see it's going up in 14s every time. That means this number also went up by 14. Or if you want to go backwards, you take away 14. So let's do 82 minus 14. So I'm just going to do step by step. So 2 take away 4 you can't do. Borrow from the 8 becomes 7, and this is 12. 12 minus 4 is 8. 7 take away 1 is 6, so 68. For the rest of them, you add 14 to 96, so add 10 is 106, add 4 is 110, so on. Add 14 here as well. Adding 10 is 148, and adding 4 more, 152. So just a quick way to add. So always partition 10 and 4. And that's it. Moving on. All right, question 2, guys. So the table shows the temperature at 9 a.m. on 3 days in January. Okay, so we're talking about 3 non-consecutive days. So this is per week. So 1st of Jan, 8th of Jan, 15th of Jan, so every week. What is the difference between the temperature on the 1st of January and on the 8th of January? Well, an easy way to do this, if you think of this as a number line, so I'm going to do thermometer. So this is the 0 mark. You got +5 here, and you got -4 here. Think carefully, because the difference between these two is 4, and the difference between these two is 5. So the total difference is 9 degrees. Okay? On the 22nd of January, the temperature was 7 degrees lower than on the 15th of January. What was the temperature on the 22nd of Jan? So wherever 15th was, it was 1 degrees. And then the following week, on the 22nd, which is after this, it goes down by 7. So again, let's look at this carefully. So if you draw a nice little number line or thermometer, put this as 0 and +1, you're going down by 7. So first you go down 1, so that's -1, and you need to go down 6 more. So of course, from 0 minus 6, you must be at -6. So -6 degrees Celsius. Okay, good stuff. Number 3. A clock shows the time twice a day. Ooh. So currently this clock is showing what? So if you know your clocks, this is between 2 and 3, but it's close to 3 p.m. So this is actually 2, and then on the minute side, it's over here, so 45. Take the 2 digital clocks that show this time. Well, first things first, this is one of them, 2:45, and if you look at the 24-hour one, all you have to really do is add 12 to the hour clock. So if it's 2, then it'll be 2 plus 12 is 14. So the next one will be 14:45. All right, easy stuff. Okay, here we are, question 4. So we're given some shapes where each shape stands for a number. Okay, so looking over here, we can see that 3 triangles going upwards must total 96. So the 3 triangles here add up to make 96. However, if we look on this horizontal row, we got these 4 shapes must add up to make 100. So right over here. Now, work out the value of each shape. Okay, so let's think this carefully. So we could say on the side, 3 triangles make 96. That means each triangle, say one triangle, is going to be 96 divided by 3. Divided by 3. So let's work out here. So we can say 3 into 96. How many 3's going to 9? Goes 3 times. How many 3's going to 6? Twice. So each triangle is 32. Now for the second one, we got 2 circles. That looks like a 20. So let me just do it like this. So 2 circles plus two triangles equals 100. We know that each triangle is 32, so 2 lots of 32, so 2 times 32 is actually 64. So 2 circles plus 64 is 100. So if we remove the 2 triangles, we need to remove 64. So in your working out, 100 take away 64, what does that give us? Well, if you know your number bonds, you can do it mentally, and this should eventually give you 36. If you're not sure, you have to do some borrowing. So borrow from the 0 you can't, borrow from the 1 becomes 0, then this becomes a 10. Borrow from the 10 becomes a 9, and then this one becomes a 10. So 10 take away 4 is 6, 9 take away 6 is 3, and that gives you 36. So far we have now 2 circles must equal 36. That means if you half this number, you get 1 circle, and 1 circle is the same as 18. And that's it. So we've got 18 per circle, and triangles we have, what was it, 32. So pause this video and have a go at this problem carefully, because this is kind of like a mini algebra problem, but with shapes. It's quite a clever one actually. Number 5, write these numbers in order, starting with the smallest. Okie dokie. So the way this works, always look at the 0 values first and then the next decimal. So 5.6 is clearly big, 0, 4. So I can just tell you straight off the bat that 5.6 is the biggest, because it's the biggest integer value, or the whole number value. So it goes right at the end. And then this 4 as well is the second biggest, because the rest are 0. So it's 4.003. Now out of these 3 numbers, which one is the smallest? Well, these 2 got zeros, so now we look at the move to the next digit. Here we got a 7, a 6, so 6 is smaller than 7, 0. So this one must be the smallest because it's 0.0. So let's put that here. Then the next smallest one has to be 6 because 6 is smaller than 7, so it's 0.607. And then the middle value is 0.78. Okay, so I hope this is clear. And then again, pause this and review if you have to. Number 6. So Jacob cuts 4 meters of ribbon into 3 pieces. Ooh, so you got 4 meters right here, and he splits into probably 3 pieces. So you got 1, 2, 3. The length of the first piece is 1.28. The length of the second piece is 1.65. So 1.28, 1.65. That means we need to work out the missing third piece. Well, easy way to do this is to add up these 2 meters, these 2 pieces, and subtract it from 4. So 1.28 plus 1.65, what does it give us? 8 plus 5 is 13, carry the 1. 1 add 2 is 3, add 6 is 9, and then 1 plus 1 is 2. Now let's subtract this from 4. So let's call this 4.00, so we can match the decimal, and 2.93. So nothing take away 3 you can't do, so you have to borrow from the very first number, 4. Make it into a 3 and give this to the second, so you got 10. Cross the 10, you got 9, and pass the 1 here. So 10 take away 3 is 7, 9 take away 9 is nothing, 3 take away 2 is 1. So the third and final piece is 1.07 meters. Bravo guys, if you guys got this, well done. Give yourself a pat on the back and let's move on. So 2 marks right in the bag. Now, let's see. Okay, number 7 guys. So here are 5 angles marked on a grid of squares. Alright, let's see. So we got A, B, C, D, E. It looks like we got, I don't know, acute angles, a right. This one looks a bit like a right angle, obtuse, acute, and probably another right angle, but nah, this looks a bit too wide. So write the letters of the angles that are obtuse. So obtuse means wide angles, yeah? So wide interior angles. See, this one is kind of small here. This is a bit small. This one looks like a perfect right angle. And how do you know? Because it cuts off exactly halfway here and then halfway. It has the same length on both sides, the same incline. This one looks really wide because if it was a right angle, this point from here would also end up here. But this is stretched. So I'll say the first one is a C. Now D is clearly acute because it's tiny, it's less than a right angle. E. The E is kind of like a C's case. If you twist your head a bit, you can see it's like C, or you can just count. You can see from this corner to here is 1, it cuts off exactly half. And instead of going here, it stretches, so it's also E. So C and E. Now acute are the tiny ones, so D is obviously tiny. A is also small because it's not a right angle. So you got A and D. And the only right angle is, of course, B. Moving on. Question 8. So Olivia buys 3 packets of nuts. I do love the nuts actually. She pays with a £2 coin. This is her change. So she got 50, 20, 10, 10, and 5. So how much money does she have? So adding all this up, 50 plus 20 is 70, plus 10 is 80, plus 10 is 90, plus 5 is 95p. Okay, so she got 95p change from £2. What is the cost of 1 packet of nuts? So first things first, let's work out how much she paid in total. So the difference between £2 and 95p. So mentally, this will give you £1 5p, but to just work it out, 2.00 minus 0.95. So from £1 is 5p, extra pound 1.05. So always do £1 first, round up to £1 is 5p, add another pound, £1 5. Now for 1 packet, you got to divide this by 3 because 3 packets equals £1 5p. So here, 3 into 1.05, 3 into 1 goes nothing, 3 into, so carry the 1, 3 into 10 goes 3 times the remainder 1, 3 into 15 goes 5 times. So the cost of 1 packet is 35. Okay, number 9. Oh, so Riverdale. So this is actually a TV series I watch. Yeah, nice stuff. So here is part of the bus timetable from Riverdale to Mott Haven. So let's try and understand what this table is saying. So from Riverdale, it seems to be, for example, if you catch a 10:02 bus, you should arrive to the next stop, Kingsbridge, at 10:11, and then Fordham at 10:28, and so on, all the way to Mott Haven at 10:53. So depending which bus you enter at these times, you arrive over here at the bottom in the corresponding column, yeah? So let's have a look. How many minutes does it take to the 10:31 bus from Riverdale to reach Mott Haven? So of course, over here. Oh, so we're going from 10:31 to 11:17. What I'll do is I'll do a number line. Okay, that's quite bent. But anyway, you start at 10:31 here. And let's say this is the next hour, 11 p.m. And then the final one is 11:17. So first things first, how do we get from here to here? How many minutes is that? Well, if you know your number ones to say the next hour, this is exactly 29 minutes. So remember, you need to get to 60, so 29 minutes. And from 11 to 11:17, of course, is 17 more minutes. Now, the total journey, add them up, so 29 plus 17. The trick is to just add 30 to give you 47 and go 1 back, so 46. So the total journey is 46 minutes. Now, what is the earliest time he can reach Tremont on the bus? So the earliest time, so let's see. So, oh yeah, I've missed our complete information. So Mr. Evans is at Fordham at 10:30. So this is what he wants to do. So he's at Fordham, so he's over here. So 10:30. So he can only catch these 3 buses. Okay. What is the earliest time he can reach Tremont by? Let's have a look. So if he's at 10:30, means he has to catch the 10:38 bus. That means the earliest he can arrive seems to be 10:44. Yep, seems okay to me. So you always pick the earliest. So if it's 10:30, you can't go back in time. You have to go the next earliest, which is that bus to arrive at this time. Okay, good stuff. Number 10, Emma makes a cuboid using 12 cubes. So write the letter of the cuboid that has a different volume from Emma's cuboid. So volume means we need to multiply the base times the height times the width, which is here. So let's have a look. So this is a 2 by 2 by 3 by 2 by 3. So the volume here is 2 times 2 is 4 times 3 is 12 centimeter cube. So we're looking at something with the same volume. So write the letter of cuboid that has a different volume. So this one here is 2 by 1 by 1, 2, 3, 4, 5, 6. So this will give you 12. That's the same. 6 by 2 by 1. So this is 12. 3 by 3 by 2. That looks different. 6 times 3. So this is 18. So this is 1. So C is one of them. Oh, so there's only one answer. Write the letter of the cuboid. So it seems to have one answer. So that's 8. So this will be 18. So C so far is it. Let's put C. D is 3 by 2 by 2, which is the same thing. Nope. Nope, nope. And then this one is just, looks like 12. I'm just going to go off. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Nope. So the answer is C. Let's check. Yep. Okay, here we are. So question 11, guys. So a toy shop orders 11 boxes of marbles. Let's keep a mental note of that. And then each box of these 11 contains 6 bags of marbles. That means so far we have for every box 6. So with 11 boxes, we have 6 times 11, which is 66 bags of marbles. Okay, let's keep that mental note. And now for each bag of these 66, there are 45 marbles. So altogether we have 66 times 45 marbles. Okay, so what they want us to do here is using our math skills and our long multiplication skills to work out the total number of marbles. So I'm going to make my life easy and just use the grid method now. So I'm going to put 6 here, 60 and 6 by 40 and 5. I'm just going to multiply everything across. So 6 times 4 is 24 with 2 zeros, 2400. 6 times 4 is getting 24 but with 1 0. 60 times 5 is 6 times 5 is 30 with a 0. 6 times 5 is 30. Now adding up all these figures, so we got, let's see, let's put some space, 2400. Next number is 300, 240 and 30. So I'm going to total them up here. So you got nothing over here. Add all these digits, 0, 0, 4 and 3 get 7. 4, 3, 2, so 4 plus 3 is 7, plus 2 is 9, and 2. So the answer should be 2,970 marbles. Yep, easy enough. Let's move on. Question 12. So a triangle is translated from position A to position B. Okay, so it's the same shape, but translation literally means has moved. So you go find the X and Y. Like how many has it moved to the X and to the Y? Complete the sentence. So the triangle has moved a certain number of squares to the right and certain numbers of squares down. So how do we know? So what I just pin a point on the triangle, which I usually use as the bottom left corner. So point the same corner and see exactly how far I traveled. So traveled 1, 2, 3, 4, 5, 6 to the right. So 6 to the right. And how many down? So 1, 2, 3, 4, 5. So downwards by 5. And we just fill out the boxes. The triangle has moved 6 squares to the right and 5 squares down. Okay, next question. So Laura chooses a number less than 20. So an unknown number less than 20. So let's call this unknown number n, and it's less than 20. She divides it by 2 and then adds 6. So n divided by 2 and then adds 6 to it. She then divides this result by 3. So whatever this result is, divided by 3, and our answer ends up being 4.5. What was the number she started with? So what we need to do this in reverse. So from 4.5, we need to multiply by 3. So multiply this by 3. So we're going to have now n over 2 plus 6 equals 4.5 times 3. And then we're going to subtract 6. So let's work this out. 4.5 times 3. So to do this, just do on the side, times 3. 3 times 5 is 15. 4 times 3 is 12, add 1 is 13. And because we have one decimal shifted, it should be here. So it's 13.5. So we can just rub this quantity out and say 13. Whoa, don't know what happened there, guys. Would equal 13.5. Now we work in reverse. So we subtract 6 to this number, so n over 2. So 13 take away 6, so you do whole number of whole number. 13 take away 6 will give us 7, so 7.5. And now we multiply this value by 2. So because we're dividing by 2, we can do the reverse. So n equals 7.5 times 2. And what is that? So just double number. So the way I do it, we know that double 7 is 14 and double 8 is 16. And so 7.5 is in between, so it's 15. And this is less than 20? It is. And that's it. So the answer is 15, guys. Okay, let's move on. Okay, number 14, guys. So looks like we're almost there. So I don't know how many left, but I think we're near the end. So complete each sentence using a number from the list below. Okay. So we got various numbers: 120, 240, 600, 1,440, 3,600, and 6,000. So let's read the statements. So there are something seconds in an hour. Oh, so this is not so bad. So first we know there are 60 seconds in a minute. That means there must be, and for a minute, we need to times it by 60 again to get hours. So this means for seconds, there must be 60 times 60 seconds to get a certain number of hours, to get 1 hour. So 60 times 60. Now what is this? So quickly do it. So 6 times 6 is 36 and then 2 zeros. So the first value must be here, 3,600. And that looks good to me. Now there are something minutes in a day. All right, this isn't so bad. So how many minutes are there in an hour again? So we know there are 60 minutes in 1 hour, and we know there are 24 hours in a day. So it's going to be 60 times 24 minutes in 1 day. Okay, 60 times 24. So let's do it again. Quick maths here. So 60 times 24. So what you could do, you could just do 6 times 24 and then add a 0 to your answer. So let's have a go at that. So 24 times 6. Now 4 times 6 is, it's 24 as well. And then 6 times 2 is 12. Add 2, which is 14. And then because we're doing 60, just stick a 0. So 14, 40, that means, it's over here. And that's it. This is all you have to do, guys. That's it. So if this is okay, if you're not sure, pause it and watch the video again and carefully understand what the statement was. Usually they're going to give you something relatable, so you don't have to. So try and know your calendar months and your hours and your minutes by heart. Yeah, it's quite important at this stage. So anyway, let's move on. 15. So complete this table by rounding numbers to the nearest 100. Oh, so this is easy. So nearest 100. Okay, so that means your answer has to end in usually a double zero. Okay. So 20,906. Well, the nearest 100, since the digits here is less than 50, it's going to be 20,900. Now this number here, because it's 90 here, it rounds up to the next 100, so it's 2,100. And this number here, because it's 9, so it's just going to go round down to 200. Very easy actually. 16. So 6 small bricks have the same mass as 5 large bricks. Okay, that's some really heavy bricks. Now, the mass of one small brick is 2.5. So one mass is 2.5. And because there's 6 altogether, this is 2.5 times 6. What is the mass of one large brick? Okay, so let's find out firstly the mass of all this. And for each large brick, we can just divide the answer by 5. So the total of this one for each brick is this answer divided by 5. All right, so let's do our mass. So 2.5 times 6. So let's do a quick long multiplication. 6 times 5 is 30, carry the 3. And 6 times 2 is 12, add 3 is 15. So it's, okay, so it's exactly 15. So the mass here, the total mass is 15 kg. Now, this is straightforward. Now, to find each large brick, you divide the answer by 5. So 15 divided by 5. Let's do it. 15 divided by 5 is just simply 3. Okay, good. Okay, number 17. Here we go. So here are 5 triangles on a square grid. All right, so it looks like we have various triangles. So we just have to probably just have a quick look at them. So one with length 5, length 1, and so on. So 4 of these triangles have the same area. Which triangle has a different area? Okay. So how do you calculate area of a triangle? So area is always half times base times height. Okay. So let's just keep that in mind. So the height is usually the vertical height. So the height going straight across, upwards. So let's have a look. So the first triangle A has a width of 5 and a height of 1. So 5 times 1 is 5. Half of 5 is 2.5. So likely most of them must have 2.5. Next one is 6 across here and 1. 6 times 1 is 6 times, and half of that is 3. So B is 3. Let's look at C. So C is 3 times 2, which is 6. Half of 6 is 3. Okay, so it looks like the answer is going to be A, I guess. Same thing for D. 3 across 2 up, so 6. Half of 6 is 3. 2 across 3 up, half of it is 3. So it must be A. Nice. So actually we got this right in the beginning. Is it just letter, right? Yep. So the diagonals of this quadrilateral cross at right angles. Yep, I can see that. So cross is, it's like a perfect right angle all across. All of these are right angles. Take all the quadrilaterals that have diagonals which cross at right angles. So you can carefully see. So let's have a look. That cross at right angles. So these cross at right angles. So here's a right angle here. So this is the, so take all quadrilaterals. So let's take this one. This one, yep, they have diagonals. Okay, so let's have a look. Nope, this one doesn't seem like it does. See, none of these are right angles, so this is false. A square would, yep, because it has a symmetrical length and width. So if you use a straight line, you can see that you get perfect right angles. Or a quad, this kind of shape as well, so a parallelogram. I wish I had my ruler, but unfortunately you can't. Unfortunately, this one doesn't cross that. Or does it cross a right angle? If you look at it carefully. So yeah, so basically this is false. So these two are false, and this is the only correct ones. So for any shapes with quadrilaterals that have diagonals which cross at right angle, it's only going to be a kite and a square. Okay, parallelogram and a rectangle doesn't have it, unfortunately. So it should be these two. Okay, let's go. Okay, so where are we? So question 19. So circle two numbers that multiply together equal 1 million. All right, easy stuff. So we should know firstly that in this case we need to multiply a 2 and a 5 because that's the variable, and this will give you a 10. Now we just need to count up enough digits to get exactly 5 more digits, because 1 million looks like this. It has 5 more zeros. So let's have a look. 2 and this one, yep, these two give you 5 more zeros. So yep, these are the ones. All right, easy stuff. The other one will give you, well, I think 1 billion or something or less. Now 20. So Laura has some money. She spent £1.25 on a drink and £1.60 on a sandwich. She has 3/4 of her money left. How much money did she start with? Okay, so drink plus sandwich, and then whatever the total is, this is 3/4 of what she has left. So if you add up both these quantities, both these money values, you should get exactly £2.85. Now this tells you that she has, this is the same as 3/4 of her money. So the way to do this then is to actually realize what the 1/4 that was left, and to do it we need to divide this value by 3 to find 1/4 and add it up. So over here, let's divide this quantity by 3 so we can find 1/4 to add it up. So 3 into 2 doesn't go, carry the 2. 3 into 28 goes, let's see, 9 times because of 27, remainder 1. 3 into 15 goes 5 times. So 95p represents 1/4. That means the total amount of money she had for 4/4, the full amount, would be adding these values. So 285 plus 95p. 5 at 5 is 10. 1 plus 9 is 10 plus 8. So it's 18, carry the 1 and 3. So the total original amount she had was 3. And here we are, guys, the final question. So question 21. I think it's the last one. Yep, end of test. Okay, so we're given an equation, 5,542 divided by 17 gives us 326. Now explain how you can use this fact to find the answer to 18 times 326. Okay, this is an interesting question because the idea is to use what we have here and to be able to find this quick and easy way to solve this equation. So since if we divided these two numbers we get 326, we can assume that this original value can simply be added by an additional 326 to get this solution here. You see that? Here we go. So we could say in a solution, explain how you can use this. So we can add 326 to 5,542 to find out the result of, let's have a look, of 18 times 326. Yep, in other words, you can just say, which is equal to 5,542 plus 326. And that's usually it. I mean, let me just double check the marking. So you have various answers too. So additional ones can be said this: an explanation that shows that 5,868 can be made by adding 326 to your original result. Example. So you could simply just said 5,542 plus 326 equals 18 times 326 is just like what I done. Or you could say that this quantity is 326 more than that. Or you could say because this is the same as 17 times this value. So you got quite a lot of options. However, be careful how you answer this. Do not say something vague. Do not accept that an explanation can simply be made. So you cannot just calculate and get the answer, because that's not what they asked. They want you to show how could you use the original equation to get the next answer. Also, don't accept vague, so try to be clear, yeah? Try and get to the point. Don't say you could add another value, which is true, but add it to what? To the original value, yes, but not just say add it. So carefully look at this and yeah, make your best conclusion. Always try and refer back to the original statement, yeah? So there's always a pattern, you have to spot it. But yeah, other than that, guys, thank you for watching, and I hope this video helped, yeah? So have a quick look, and if you enjoyed this, please give this video a big like, yeah? That would be very helpful. And subscribe, so you know that would also help me produce more videos too. But other than that, I want you guys to have a nice day and focus hard on your SATs, and good luck with everything else. So I just want to say ciao.